This video is all about comparative analysis of liquids pipeline hydraulic calculation. Now we are comparing hand calculation in Shashammenon book in example 3.4 as against the pipe flow expert software. Now we're going to use pipe flow expert software to solve that particular problem, and now compare the results to see the percentage error as in compared to hand calculation as against the pipe flow experts. Now look at the question. This is the question. It says consider a 100-mile pipeline, 16 inches diameter, 16 pipeline 16 inches diameter. So now, and the wall thickness is 0.250 inches. The specific gravity of 0.815 and viscosity of 15 centistokes and 70 Fahrenheit at a flow rate of 90,000 barrels per day. Calculate the friction factors and the pressure drop per unit length of pipeline using the Colebrook-White equation, assuming a pipe roughness value of 0.002. Now, this is the result from Shashammenon book for example 3.4. These are the results. The friction factor is 0.0229. The pressure drop per length is 10.24 psi per miles. Then the total pressure drop is 1024 psi. So now this is for that of hand calculation from this particular book. Now let's now use pipe flow expert. But before we use pipe flow expert, okay, let me just explain. Now in pipe flow experts, in flow in units, okay, it's supposed to be in imperial, which is imperial, is not in meter, because the whole question is in the whole the parameters are in imperial, that is English units. Now the flow rate, why I'm coming here is that the flow rate here has barrel per day. Now but the flow rate here, let me just add a node. Now if I add a node, let's say I want to make changes. Let me say I want to add demand N. Now for this demand N, the units here, there is no barrel per day in this unit. So the one we are supposed to use that is closer to what we want is US gallon per minute. So now that is, we're going to change all our information, the flow rate in US gallon per minute. And again, if you look at the unit again, the length, there is no miles. So the closest we can do that, we can change to is feet. So we're going to change the length to feet. Now again, if you look at the units, the fluid, the viscosity is in centipore. So we need to change the viscosity from centistoke to centipores. So that is all we needed to do. Then now we now model the fluid we are going to use, and also model the system in order to solve the problem. So what we're doing now is first we're going to do conversion. So the conversion, we're going to do the conversion in Excel. So now they gave us 90,000 barrel per day. We need to change it to gallon per minute. So to do that, I'll say equal to, I will now use a conversion formula here. Now this is the number. We'll select the number. Then from which unit? From barrel. From barrel to gallon. Then divide by, it's barrel per day, so I need to convert day. I need to convert day. So 1 day, I need to convert 1 day by dividing. It's barrel per day, so I would divide the conversion. I would divide the conversion I had in day on that particular whole, so that it will now give me the proper conversion. So now I will convert 1 day to minutes. Now we'll enter. So this is the conversion, which is 2,625 gallons per minute. So now we have in miles, we have 100 miles. We need to change the miles to feet. So to change the miles to feet, I will now also use the conversion system. So now I will now, for number, I will select this, put comma, then the mile is mi, comma, then I need to convert it to what? Feet, ft. Now or enter. So this is the value for ft conversion. So now this is the value for ft conversion. Now the centipulse, they gave us 15 centistokes, so we have 15 centistokes. Now they also gave us specific gravity, 0.815. Now they gave us the fluid, the water density at 70 degrees Fahrenheit. Now for us to do that, let me go into the internet. Let me go to internet and look for the density of water at 70 degrees Fahrenheit. So the density of water at 70 degrees Fahrenheit is 62.30. Now let's also, since we are working with this software, we are going to look at the software. Let's go to the fluid. Let's say water, the density of water. So the one that is close by is 78.000. So now we're going to use the density of this water at 78 as that of 70, because that of 70 and 68 should be the same, should be closer. So that means there will be no difference. The difference will be minimal. So what we're going to use, the density we're going to use is 62.303105. Now that is what we're going to use. So now let me go to this. So now we'll just type in that same density, 62.30, 62.330. Let's say 303,105. Now the density, let's go back to, let me go back to this. Now the density, specific gravity is the same thing as the fluid, the same thing as the fluid density divided by the water density. So for us to get the fluid density, it will now be specific gravity times the density of water, which will give us 0.815 times 62.303105. If you multiply this, it will give us 50.777030575 pounds per feet cube. Now, so we're going to go back to the spreadsheet. So now this density will now be equal to the specific gravity times the density of water, which gives us this. So now we're done with this. So now we can now define the fluid. We can also make use of the length, the flow rate in this particular software. Now these are the results from the hand calculation in the Shashemenon book, which is this. So this is the friction factor, this is the pressure drop per length, this is the total pressure drop. So now let's go back to, let's now go to our Pipe Flow Expert software. So now we have defined this. We need to change this unit to the flow rate to US gallon per minute. US gallon per minute. That's it, US gallon per minute. I will save this as default option. Okay. Now say, I will not say okay. That is it. Now I'll come here. I need to change this to this. Now the in gallons per minute, the flow rate in gallons per minute is 2625. So now we need to put in a demanding flow into the pipe, which is 2625, and is the same thing as 90,000 barrel per day. So in US gallon per minute, it will be 2,625 US gallon per minute. So now I will just say okay. So it's added. Now I will now add a pipe from here to this point. Now I need to define, now we need to also define the material. The material in this case, they said the roughness. Okay, I have added this material before when I was doing, there was a job, there was a particular one, the one I did last. So I will still use this steel because the material is of internal roughness 0.002, which is the same with this particular question. So I will make use of this. Now the wall thickness for the pipe is 0.250, so which is the same with this, and it's just the same with this. So and a 16-inch nominal size. So I will select this. I will save. Now we have made the changes here now. So now, but the length of pipe is 100 miles, but in feet is 528,000. So we've done that. We'll just say we'll now okay it. So we've gotten this. Now we need to change this joint to tank. Now I'll leave the tank empty, so because the thing will empty, the thing will flow from this end, that is from node 1 into node 2, and emptying the fluid into node 2. But now before we proceed, we need to model the fluid, because now we have not modeled the fluid. So to model the fluid, we'll come here, we'll make changes. The fluid we are going to use, we need to model it. So okay, look, I have modeled it before, but I will need to delete this so that I will remodel it, so that you will see how it is being done. So let me just remove it. So to remodel it, you look through, you see that the only one closer to the viscosity is this 12.3, which is this chemical, and the density is off. So now that means we need to model the system. So now for us to do the modeling, we just add fluid, just click that add new button, fluid. Now the fluid, we are going to call it, because the density, having a specific density of 0.815, it is said to be oil. So now let me just call it heavy oil. It's not a heavy oil anyway, but let me just give it that name. The formula I don't know, so I will just say not applicable. Now is 70 degree Fahrenheit. The pressure is 0.000. The density we got, I haven't calculated that, we got 50.777031. Then the centipulse we got is 12.225. That is the centipulse we got. So now the vacuum pressure, this is not applicable, but I will just use this, since we can make use of this. Let me just make an approximate value. So I will just say 450, although we don't have it, because although the vacuum pressure is not applicable to this case, since there is no pump. If there is a pump, then we need to find the exact vacuum pressure. So I just put an arbitrary number, because it's not applicable to this particular problem. So I will just click add to fluid data. I'll say yes. Now this is selected, so I will just transfer selected fluid. So that is it here now. So now I will just say save. So we are done. So now we have modeled the fluid, we have modeled the system. So now we need to do, what we do next is to run the calculations. So the calculation is done. Let's look at the results. So now looking at the results, we have our friction loss, that is the head, the feet head, 2904.68. So that is what we got. Now let's go to now here the total loss is 1024, that is 1024. So the total loss is 1024.2437. So now let's go to Excel. So we need to add all this. We have the total pressure drop to be 1024.2437. Here is 100 miles. Then this value for pipe flow expert will now be equal to the total pressure drop divided by the length of pipe. So it will give us 10.2437 psi per mile. So now we are good. Now let's look at the velocity. Since from the charts pipe flow expert did not calculate the friction loss. It doesn't calculate friction loss here. So but we're going to use, there's no friction loss, so we are going to use formula to be able to calculate our friction loss. For us to do that, I will just make some explanation on what we're supposed to do. Now, you know that the head loss is the same thing as friction factor times the length of the pipe divided by the internal diameter times velocity square all over 2g. Now you now have the length is in feet, this one is in inches. So what we're going to do now is we say this is dimensionless times this one that is in length that's in feet. We need to convert this to inches. So 12 inches is equivalent to 1 foot. So we have done that to this. So this one is in inches already. So the whole of this will be dimensionless because this one is in inches. We have converted this one that is in feet to inches. But when this one cancel out this whole of this will not be dimensionless, although it's dimensionless already, but because the units are not the same, it cannot cancel out. So now, because this one is feet, this one is inches, so you have 12 here. Then this is v square, this is v square over 2g. So we now have 12 FL all over D times v square all over 2g. So now let's come over to this. We're looking for F. So the F, making F the subject of formula. So we'll say F will now be equal to the head loss times internal diameter divided by 12 L times 2g divided by v square So now, so this is the formula we're going to use. This is the formula now, so we're going to use. So now we're going to go back to Excel. We're going to go back to Excel to do that. So now, going back to Excel, we need velocity, we need acceleration due to gravity, which is 32.2. We need internal diameter, which is 15.5. We need the head loss, which we got from the pipe flow expert to be 2904.8 68 feet head. So now this is what we got. So now the velocity, let's go back to pipe flow experts. The velocity, let's look for the velocity. The velocity here is 4.463. So 4.463, that is what we're going to use for the velocity. You see, this is the friction loss head, that is the head loss, which is what we use now, what we're using. So now let's go back to Excel. In Excel, so now we are going to type in the velocity, which is 4.463. That is all for now we need. So that is all for now we need. So now, but for the length, since we need length, the length of pipe here, the length of pipe in feet, let me just put it in feet. So what we got was 528,000. Got it here. 528,000. So now that is what we're going to use to calculate our friction factor for pipe flow expert. So now we say equal to the head times the internal diameter this divide by bracket open 12 times the length of pipe, bracket close, times 2 times acceleration due to gravity divided by velocity squared. So let's expand. Okay, let's expand this. So this is what we get. So now let's look at the percentage error. The percentage error will now be this value. Okay, no, let me just say this value minus this value divide by this one, enter, times 100. So let me expand this a little. Let me bring it down to this. So these are the percentage error. You see, the hand calculation and that of the software is close. So it's very close. So there is no much error. The error is not up to 1%. So that is good. So if you like this video, please subscribe to my channel and hit the notification bell, and also do well to share this video. Thank you.